Afternoon, everyone. I'm Rezel Hilonggo, and I hope you're all doing great today because for today's lesson, we will be tackling about the ozone depletion. When you go at the beach, do you use sunscreen? Why do we have to use sunscreen, by the way? We use sunscreen because we wanted to protect our skin from the ultraviolet rays that is coming from the sun. Have you ever had a sunburn? This is when you realize how important to have protection towards the heat of the sun. Do you also know that our Earth also has its own form of sunscreen? This is what we call the ozone layer. The ozone layer is a region in the Earth's stratosphere that protects the Earth from the harmful ultraviolet radiation of the sun. But before digging in, we will first define what is ozone depletion. Ozone depletion is a gradual thinning of the Earth's atmosphere or Earth's ozone layer in the upper atmosphere caused due to the release of chemical compounds from industries or other human activities. So, as we all know, technology keeps on inventing new things that could help us in making our works easier. But despite of the benefit it brings, it can also harm the atmosphere that would also affect us. How have we depleted ozone in the stratosphere and what can we do about it? Concept 15.7a, widespread use of certain chemicals has produced ozone levels in the stratosphere and allowed more harmful ultraviolet or UV radiation to reach the Earth's surface. So later on, we will discuss what is the certain chemicals that affect or that makes our ozone layer thin. Concept 15.7b, to reverse ozone depletion, we must stop producing ozone depleting chemicals and adhere to the international treaties that ban such chemicals. So later on also, we will also tackle about this. What are these international treaties that is the program of banning the use of chemicals that can deplete the ozone. And so we will proceed. Our use of certain chemicals threaten the ozone layer. So the ozone layer is in the stratosphere is a vital form of natural capital that support life on land and in shallow aquatic environments. In what way? So this the ozone layer helps us. The ozone layer traps UV radiation or light that can penetrate organism protective layers like skin. It can without ozone layer, the ultraviolet rays damage molecules in plants and animals. So researchers shows a considerable seasonal depletion or thinning of ozone concentration in the stratosphere above Antarctica and above Arctic since 1970. The loss of ozone over Antarctica has been called as ozone hole. A more accurate term is ozone thinning because the ozone depletion varies with the altitude and location. Based on these measurements and models, the overwhelming consensus of researchers in this field is that ozone depletion in the stratosphere poses a serious threat to human, other animals, and some primary producers, mostly plants that use sunlight to support the Earth's webs. So later on, we will tackle about what is the effect of ozone depletion to humans, to animals, and to plants. The origin of this serious environment threat began when the accidental discovery in the first chlorofluorocarbon, or the CFC. So the CFC is what I am talking a while ago, the certain chemicals that affect or that contributes to the thinning of the ozone layer. Chemists soon developed a familiar compounds to create a family of highly useful CFCs known by their trade name freons. So before CFC is like a dream chemicals to the inventors, because of this the freons, which is because of freons become popular as coolants in air conditioners and refrigerators, propellants in aerosol spray cans, cleanser for electronic parts such as computer chips.
Good day everyone, I am Evanie Barbero and today I will be reporting about air pollution. So, what is air pollution? So, air pollution is the presence of chemicals in the atmosphere in concentrations high enough to harm organism, ecosystem, or human-made materials or to alter climate. So, almost any chemical in the atmosphere can become a pollutant if it occurs in high enough concentration. So, the effects of air pollution range from annoying to lethal. This means that it's unhealthy to our health and body, and also air pollution can harm human beings. So, air pollutants come from natural and human source. Will be explained in the next slide provided. For natural sources, it includes the wind-blown dust, pollutants from wildfires and volcanic eruptions, and volatile organic chemicals released by some plants. In areas experiencing volcanic eruptions or forest fires, chemicals emitted by these sources can temporarily reach harmful levels. So most natural air pollutants are spread out over the globe and diluted or are removed by chemical cycle, precipitation, and gravity. But in areas experiencing volcanic eruption like in the Philippines, it belongs to natural sources of air pollution. So human sources or human inputs is most human inputs of outer air pollutants occur in industrial and urban areas where people, cars, and factories are concentrated. These pollutants are generated mostly by the burning of fossil fuels in power plants and industrial facilities, or stationary sources, and in motor vehicles or mobile sources. So usually in human sources or human input happens in urban areas where most populated area belongs there and most of the buildings that causes air pollution are there. So next, scientists classify outdoor air pollutants into two categories, which are primary pollutants and secondary pollutants. So, primary pollutants are chemicals or substances emitted directly into the air from natural processes and human activities at concentrations high enough to cause harm. So, secondary pollutants, while in the atmosphere, some primary pollutants react with one another and with other natural components of air to form new harmful chemicals it is called secondary pollutants. So, outdoor air pollution was once a regional problem limited mostly to cities. Now it is a global problem largely due to the sheer volume of pollutants produced by human activities. So the secondary pollutants is produced by human activities. There is no place, as a matter of fact, there is no place on the planet's surface that has not been affected by air pollution from human activities. So as you can see in the picture, this is the natural source, the volcanic eruption. Human source, which is the car, the auto parts. Then natural source and human source created the primary pollutants. So that is where the most other hydrocarbons, most suspended particles. So the stationary human source and the primary pollutants created the secondary pollutants. So what are the major outdoor air pollutants? So there are 6 major outdoor air pollutants, which are carbon dioxide, nitrogen oxide and nitric acid, sulfur dioxide and sulfuric acid, particulates, ozone, and lastly volatile organic compounds or VOCs. So carbon dioxide is a colorless, odorless, and highly toxic gas that forms during the incomplete combustion of carbon-containing materials. Major sources are motor vehicle exhaust, the burning of forests and grasslands, the smokestacks of fossil fuel burning power plants, industries, tobacco, smoke, open fires, and efficient stove used for cooking or heating. So those sources produce carbon oxides. So long-term exposure. So how could it affect to human health? So long-term exposure can trigger heart attacks and aggravate lung diseases such as asthma and emphysema. At high levels, carbon oxide can cause headache, nausea, drowsiness, confusion, collapse, coma, and worst is death. The next one is nitrogen oxide and nitric acid. This is a colorless gas that forms when nitrogen and oxygen gases react under high combustion temperatures in automobile engines and coal burning power and industrial plants. So how it will affect in the health of human. So at high enough levels, nitrogen oxide can irritate the eyes, nose, and throat, aggravate lung ailments such as asthma and bronchitis, suppress plant growth, and reduce visibility when they are converted to nitric acid and nitrate salt. So next one is sulfur dioxide and sulfuric acid. Sulfur dioxide and sulfuric acid is a colorless gas with an irritating odor. About 1/3 of the SO2 in the atmosphere comes from natural sources such as volcanoes. They can damage crops, trees, soils, and aquatic life in lakes. And they corrode metals and damage paint, paper, leather, and the stone used to build walls, statues, and monuments. So let's move forward to particulates. Particulates consist of a variety of solid particles and liquid droplets that are small and light enough to remain suspended in the air for long periods. These particles can irritate the nose and throat, damage the spine, toxic particulates such as lead and cadmium can cause genetic mutation, reproductive problems, and cancer. Particulates also reduce visibility, corrode metals, and discolor clothing and paints. So ozone, we are all familiar with ozone. So one of the major ingredients of photochemical smog is ozone, a colorless and highly reactive gas. So scientific measurements indicate that some human activities have decreased the amount of beneficial zone in the stratosphere and have increased the amount of harmful ozone in the troposphere near ground level, especially in some urban areas. So volatile organic compounds is such as rice puddles, landfills, natural gas wells, and pipelines, and come mostly from decomposing other fuels are liquids that can evaporate quickly into the atmosphere. So the rest come from human source such as rice puddles, landfill. Oh, sorry for that. It's typographical error. So there are several factors can decrease or increase outdoor air pollution. So the 5 natural factors help reduce outdoor air pollution is first, particles heavier than air settle as a result of gravitational attraction to the earth. Second, rain and snow partially cleanse the air of pollutants in the other country not applicable in the Philippines, only the rain. So third is the salty sea. Spray from the ocean washes out many pollutants from air that flows from land over the oceans. So the fourth one is when sweep pollutants away and dilute them by mixing them with cleaner air. So yeah. And the fifth one is some pollutants are removed by chemical reaction. For example, SO2 can react with O2 in the atmosphere to form SO3, which reacts with water vapor from droplets of H2SO4 that fall out from the atmosphere as acidic precipitation. So there are 6 other factors can increase outdoor air pollution. First is urban buildings, low wind speed and reduce the dilution and remove of pollutants. Second, hills and mountains reduce the flows of air valleys below that allow pollutants to build up the ground level. Third is the high temperature promotes the chemical reaction leading to the formation of photochemical smoke. Fourth is the emission of volatile organization compounds from certain trees and plants in urban areas that can promote the formation of photochemical smog. So how should we deal with air pollution? So there are legal, economic, and technological tools that can help us to clean up air pollution, but the best solution is to prevent it. So in preventing it, we must start in ourselves. Discipline, and we must follow the rules to prevent air pollution. So what can you do? So test for radon and formaldehyde inside your home and take corrective measure as needed. Do not buy furniture and other products containing formaldehyde. Test your home or workplace for asbestos fiber levels and check for any crumbled asbestos materials. If you smoke, do it outside or in closed room vented to the outside. Make sure that the wood burning stoves, fireplaces, and kerosene and gas burning heaters and properly installed, vented, and maintained. Install carbon monoxide detectors in all sleeping areas. Use fans to circulate indoor air. Grow house plants the more the better. Do not store gasoline, solvent, or other volatile hazardous chemicals inside a home or attached garage. Sorry for that. Remove your shoes before entering your house to reduce inputs of dust, lead, and pesticides. You can reduce your exposure to air pollution by doing the following, as stated above. So, let me end my discussion with this question. Which three of these articles do you think are the most important ones to take and why? That's all. Thank you.
Good day. My name is Kristine and I'm here to report about climate change. So let's talk about climate change. Over thousands of years, the levels of carbon dioxide in the atmosphere is low. However, during the spike of industrial revolution that took off around 1950s, it gradually increases. Human activities from pollution to overpopulation are driving up the Earth's temperature and fundamentally changing the world around us. So what is climate change? Climate change is the global phenomenon of climate transformation, characterized by the changes in the usual climate of the planet regarding temperature, precipitation, and wind, and are especially caused by human activities. As a result of unbalancing the weather of Earth, the sustainability of the planet's ecosystems is under threat, as well as the future of humankind and the stability of the global economy. In thinking about climate change, it is very important to distinguish between weather and climate. According to the World Meteorological Society, weather consists of short-term changes in atmospheric variables such as the temperature, precipitation, wind, and barometric pressure in a given area over a period of hours or days. By contrast, climate is determined by the average weather conditions of the Earth or of a particular area, especially temperature and precipitation, over periods of at least 3 decades to thousands of years. Climate change is neither new nor unusual. Over the past 3.5 billion years, the planet's climate has been altered by factors such as volcanic eruptions, changes in solar input, continents moving slowly atop shifting tectonic plates, impacts by large emitters, the planet's wobbly orbit around the Sun, and the fact that the Earth is tilted in its orbital plane. According to NOAA's 2020 Annual Climate Report, the combined land and ocean temperature has increased at an average rate of 0.13 degrees Fahrenheit per decade since 1880. However, the average rate of increase since 1981 has been more than twice that rate. About 97% of the world's climate, scientists agree that climate change is happening now and is caused mostly by human activities, especially deforestation and the burning of carbon-containing fossil fuels. The picture shows scientists extracts ice cores from deep holes drilled into ancient glaciers at various sites, such as this one near the South Pole in Antarctica. Analysis of these ice cores yields information about the past composition of the lower atmosphere, temperature trends, solar activity, snowfall, and forest fire frequency. Figure 15.21 shows between 1913, which is the top photo, and 2008, which is the bottom photo, much of the ice that covered Superior Glacier and in Montana's Glacier Natural Park melted. This photo shows the result of climate change. The main cause is the phenomenon known as the greenhouse effect. The natural process called the greenhouse effect plays a major role in determining the Earth's climate. It occurs when some of the solar energy absorbed by the Earth radiates into the atmosphere as infrared radiation. This radiation interacts with molecules in the air, especially the 4 major greenhouse gases, which is water vapor, carbon dioxide, methane, and nitrous oxide. It increases the kinetic energy of air molecules and warms the lower atmosphere and the Earth's surface. Life on Earth and human economies are totally dependent on the greenhouse effect, one of the planet's most important forms of natural capital. It keeps the planet at a comfortable average temperature of around 15 degrees Celsius. Without it, the planet would be a frozen, uninhabitable place. Let's talk about the greenhouse effect. The greenhouse effect is a natural process that warms the Earth's surface. When the sun's energy reaches the Earth's atmosphere, some of it is reflected back to space, and the rest is absorbed and re-radiated by greenhouse gases. The absorbed energy warms the atmosphere and the surface of the Earth. Human activities like the burning of fossil fuels have increased the emit of carbon dioxide in the atmosphere by more than a third since the Industrial Revolution. The rapid increase in greenhouse gases in the atmosphere has warmed the planet at an alarming rate. So, what can we do to slow projected climate change? We can reduce greenhouse gas emissions and the threat of climate change while saving money and improving human health if we cut energy waste and rely more on cleaner renewable energy resources. There are two basic approaches to dealing with the projected harmful effects of global climate change. One is mitigation. Mitigation is to try to slow it down in order to avoid its most harmful effects. Mitigation includes reducing GHG emissions, enhancing GHG sink strength, long-term focus on avoiding future impacts. And adaptation is to recognize that our current failure to sharply reduce our contribution to the atmospheric warming means that some climate change is unavoidable and that we will now have to try to adapt to some of its harmful effects. Adaptation includes reducing vulnerability, enhancing adaptive capacity, and start with focus on current variability. Solutions include prevention, cut fossil fuel use, shift from coal to natural gas, repair leaky natural gas pipelines and facilities, improve energy efficiency, shift to renewable energy resources, reduce deforestation, use more sustainable agriculture and forestry, put a price on greenhouse gas emissions. While clean up, sequester CO2 by planting trees and preserving forests and wetlands, sequester carbon in soil, sequester CO2 deep underground, sequester CO2 in the deep ocean, remove CO2 from smokestack and vehicle emissions. So what can you do as a student and a citizen of this country? To reduce the carbon dioxide emissions, you should calculate your carbon footprint, drive a fuel-efficient car or walk, bike, carpool, and use mass transit. Reduce garbage by reducing consumption, recycling and reusing more items. Use energy-efficient appliances and compact fluorescent or LED light bulbs. Wash clothes in warm or cold water and hang them up to dry. Close window curtains to keep heat in or out. Use the low-flow shower head. Eat less meat or no meat. Heavily insulate your house and seal all air leaks. Use energy-efficient windows. Set your hot water heater at 49 degrees Celsius. Plant trees. Buy from businesses working to reduce their emissions. So that's all for my report about climate change. Remember to reduce, reuse, and recycle, and save Mother Earth. Thank you.
Thank you all for listening to our report about ozone depletion, air pollution, and climate change. This is Kristine, Rezel, and Evanie. Thank you for listening.